everyone. In this video, we're going to be looking at some different types of sampling methods. So the reason sampling methods are important is that one of the central ideas in statistics relies on using a statistic from a sample to estimate the parameter of a population. So, for example, say we are looking at a population of all voters in a particular area, and we want to estimate what percentage of all voters would support a particular ballot measure. So that is our parameter. Now, because we can't really survey every single voter, we would select a sample and then poll the people in that sample and create what's called a statistic. So the statistic would be what percentage of the people that we poll who support that ballot measure. So if I select 1,000 people to be in my sample, it's going to make a big difference whether those 1,000 people were at a protest for some issue related to the ballot measure, or maybe 1,000 people who aren't politically active. We could see much different results from those two groups. Even doing a poll at certain times of day or in certain geographic zones can make a big difference in what we're seeing with our statistic from the sample versus what the parameter or the population value would be. So the goal in all of this is to have what we call representative samples. So sort of samples that don't differ in any meaningful or significant way from the overall population. Random samples have the best chance of being representative of the population. With random samples, you can still have sampling error, which is just random variations. So a random sample is never guaranteed to match the population, but it's sort of the best method we have other than doing a census and looking at every single person in the population or every single item. So the most basic of this would be a simple random sample. This is where every member of the population has the same equal chance or equal odds of being selected. This is like using a random number generator with numbers assigned to the population or choosing names out of a hat or something like that. Another type of random sample is called a stratified sample. So with a stratified sample, we're taking the population and we're actually dividing it into groups. Typically these groups will have something in common. So for example, if we're talking about political polling, we could divide up people by age or by race or ethnicity. And then from each one of these groups, so say this is an age range, people from 18 to 25 or something like that, we will select some number of people at random, just like a simple random sample from that group. And then the sample would be sort of all of those put together. Stratified sampling can be really helpful, especially if you want to compare the results from different groups. For example, looking at health statistics for different races and to see if there's a difference between them. It is worth noting that these strata might differ in size and also might differ in characteristics, so you need to be careful when analyzing the data that you're not just pulling everything together and ignoring where the sample came from. Another type of random sample is called a cluster sample. This can get confused with a stratified sample because it also involves dividing the population into a bunch of groups. These groups are called clusters. But the way we select our sample is we randomly choose a few of the clusters, and then we choose everyone or every member of each one of those clusters. So I've kind of shaded in a few of the little groups of the population, and that becomes your sample. An example of this is if you were surveying people within a particular zip code, you could randomly select blocks and then survey all residents on those blocks. Another example would be doing a customer survey for airline customers and randomly selecting a few different flights and surveying all passengers on those flights. Unlike with strata and stratified sampling, these clusters shouldn't really have anything meaningful in common. They might be different from one another, but not in any kind of systematic way. So the clusters don't represent different age groups or something like that, but more like natural groupings within the population. Because both stratified and cluster have groups, it can get confusing which one is which. So a way to remember this is that stratified, we're taking some members from all of our groups, so we're selecting at random from every single one, versus in a cluster sample, we're taking all the members of just some of the groups. So that visual or wording distinction might help you differentiate them. The last random sample method that we'll look at here is systematic sampling. So this is where every nth member of the population is selected. So for example, if you have bolts coming off of an assembly line, you could select every 200th bolt that comes out to do quality testing. I'll also just briefly mention here multi-stage sampling, which is sort of a combination of different sample methods. I'm not going to get into that one here, but it can sometimes combine different sampling methods. Finally, there are many different ways a sample might not be random. Samples that are not random are often just convenience samples. So say that you're trying to study all students at your school and you survey people in the hall outside of your class. Well, that's not going to be necessarily representative of the wider population, and it's not randomly selecting students within the school. The second category here, a voluntary sample, is when the participants actually sort of choose themselves for the sample. An example of this is asking for feedback using a poll on social media. You're only going to get responses for people who choose to answer the poll. And voluntary samples in particular tend to see stronger opinions. So you might get more polarized results from a voluntary sample. And a third concern here, non-response bias, would be, say you send out a survey to 10,000 people and those people were all randomly selected, but only 150 of the people actually completed. So if you're seeing a significantly low response rate on a survey, that could create bias because the people who actually respond might not be the same as the people who were selected for the random sample to begin with. One last thing to mention here, we love to get random samples to try and achieve a representative sample, but there's some cases where you can't randomly select, particularly in experiments. So suppose you are testing an experimental drug for people who suffer from migraines. It would be unethical and also just not really workable to just randomly select people who have migraines. People would have to volunteer to participate in such a study. There are other ways we can institute randomness in experiments, in particular using randomized treatment and control groups. You'll see more about this later, but randomness doesn't only apply to samples, it can apply to other types of study design. That's it for this video. Thank you for watching.